In part 2, I am going to talk about your study environment, a concept known as interleaving, and focused and diffused thinking. Let's look at an experiment that showed you recall more in the environment where you did your studying. So 18 scuba divers studied 36 words while they were submerged at 20 feet. 1 hour later, 9 of them took a test on land and 9 of them took the test submerged again at 20 feet. Turned out that those who took the test underwater remembered 30% more words. Let's look at another experiment of the effect of environment on learning. 2 groups studied 40 four-letter words. Each group had 2 10-minute study sessions that were separated by a few hours. Now, Group 1 was split into 2 groups. So half of Group 1 studied in a cluttered basement, and the other half of Group 1 studied in a neat, bright room. Now, Group 2 had 1 session in the cluttered basement and 1 session in the neat, bright room. So 3 hours after the last 10-minute session, the groups were tested in a third room. The one-room group, whether it was the ones who studied in the cluttered basement or the ones who studied in the brightly lit room, recalled an average of 16 words. The group that had 1 study session in the cluttered basement and 1 in the brightly lit room recalled an average of 24 words. So by studying in 2 locations instead of 1, there was a 50% improvement in the recall of the words. You should therefore vary where you study. Of course, you'll probably do a lot of studying in your room, but try to get to places like a library or even the location where you're going to be taking a test. Because if you perform better in the environment where you did your studying, it makes sense to do some of that studying in the location where you will be taking your test. These authors have shown that having some ambient noise can actually enhance learning, and the amount of ambient noise that you encounter in a coffee shop seems to be the right amount. This ambient noise causes some distraction and cognitive disfluency, so the students have to put in a little more work to process the material, and it apparently sinks in deeper. If you can't get to a coffee shop, there's actually a website that you can go to play background coffee shop ambient noise. Every semester I'll have some students tell me the actual test was harder than the practice or previous tests that I supplied to the students. I have been teaching for 35 years, so if this were true, my tests would be so hard by now that I could not take them. The difference is probably the conditions under which you took the practice test. Did you do it in your quiet room, the location where you have been doing your studying? Did you use the same time limit you're going to have during the actual exam? Were your class materials available? Did you occasionally glance at them? Was the key readily available? Did you look at the key at all during the time you were taking these practice tests? So you should actually do at least some of the practice tests under the same conditions that you're going to encounter when you actually take your test. I am going to discuss a concept that improves learning referred to as interleaving. So one example of interleaving is when you're doing space learning and you interleave different subjects. So this would be something that naturally occurs if you're a full-time student. You can also do interleaving with the same subject if you mix topics. I'll also look at an example of interleaving to develop a skill. Let's look at an experimental study of interleaving and identifying artists. So the test the students will have to take is they will be shown a painting and they will have to identify the artist. Now, no one understands exactly how people distinguish artistic styles. So the students were split into two groups. Okay, so the first group would be shown, say, 20 paintings by Monet, and then 20 paintings by Lautrec, then 20 paintings by Gauguin. Whereas the second group, the paintings were interleaved. So they may be shown 2 Lautrec paintings, 1 Monet, 3 Gauguin, and so forth. So both groups would look at the exact same paintings and the same number of paintings, but one did it in a block fashion and one did it interleaving. The students who studied using interleaving were able to identify 65% of the artists, while those who used blocked learning were only able to identify 50% of the artists. Interestingly, in a questionnaire after the final test, 80% of the participants rated the block learning better than interleaving, even though interleaving resulted in better learning. Interleaving also works for developing motor skills. Let's see that by describing an experiment that Kerr and Booth performed. They took 30 children, ages 6 to 8, and divided them into two groups. The children would practice throwing golf ball-sized beanbags from a kneeling position at bullseyes on the floor. One group practiced on one target, a bullseye that was just 3 feet away. The other group practiced on two targets, one that was 2 feet away and another that was 4 feet away, alternating their shots. But they never threw to a target that was 3 feet away. In the subsequent competition, throwing the beanbag at a target 3 feet away, the kids in the mixed target group handily won the competition. Let's look at another study of the benefits of using interleaving to learn. In this study, students are going to learn to find the volumes of some obscure three-dimensional objects like wedges, spheroids, spherical cones, and half cones. Group 1 practiced problems clustered by type. So they worked a series of problems on finding the volume of wedges, then a series of problems on finding the volume of spheroids, then spherical cones, and finally worked the problems on finding the volume of half cones. Group 2 practiced the same problems, but the problems were interleaved. So for instance, they may have worked a problem on finding the volume of a half cone, then 2 problems on finding the volume of wedges, then a problem on finding the volume of a spherical cone, then 3 problems on finding the volume of a spheroid, and so forth. On a test, the Group 1 or block learning group scored 60%, while the Group 2, the interleaved study group, scored 89%. And a test a week later, the block learning group only scored 20%, whereas the interleaved learning group scored 63%. One obvious reason interleaving accelerates math learning in particular is that tests themselves are mixed set problems. Mixing problems also forces the students to identify each type of problem and match it to the appropriate solution. The repetition with block learning creates a powerful illusion. Skills improve quickly and then plateau. But with the interleaving, that varied practice produces a slower apparent rate of improvement, but a greater accumulation of skill and learning over time. I want to talk about focused and diffused mode thinking, which both play important roles in learning. So focused mode thinking is when you're at your desk and you're really concentrating on the material you're studying. Diffused mode thinking occurs after focused mode thinking, and this is when you're not consciously thinking of what you're studying, and instead you're going for a walk, having a cup of coffee, or even sleeping. The diffused mode of thinking is described by this quote from Hermann von Helmholtz. Von Helmholtz made many contributions in many scientific fields, including the discovery of the principle of the conservation of energy. And what he said was, happy ideas come unexpectedly, without effort, like an inspiration. So far as I am concerned, they never come to me when my mind was fatigued or when I was at my table working. They came particularly readily during the slow ascent of wooded hills on a sunny day. Graham Wallas laid out the process of using diffused mode thinking back in 1926. So the first part is the preparation. So this is when you do your focused study on something like a homework problem. And you may get to the point where you just cannot solve it, so you leave it and you do something else. This is when incubation occurs. So this is when you're taking a walk, a nap, playing a sport, showering, whatever. And then at some point, when you're not consciously thinking of the problem, you have this aha moment where you figure out how to solve the problem. And then the final step is going back and verifying that you have figured out how to solve the problem. So diffuse thinking is another reason that this spaced learning works so well, because if you're doing spaced learning, you're giving yourself many more diffused thinking opportunities than if you just do one solid block study of a material. I am going to show you 3 problems that will probably require you to use diffused thinking to solve. I will not put the solutions in this video, but I will put them at the end of the 6th video in this series. That should help you resist the temptation of looking at the solutions and allow you to utilize diffused thinking to solve these problems. In the first problem, we have this series of 10 dimes arranged in a triangle. And you are to figure out how to move just 3 dimes to form a triangle that is pointing downward. I could not solve this problem when I first looked at it, so I needed diffused thinking to solve it. And in fact, I woke up the next day and had the idea of how to solve this problem. When I looked at the solution in the book where I saw this problem, I discovered that my solution was different than the solution in the book. And again, at the end of part 6, I will show you these 2 solutions. Here is the second one. You are to look at this sentence and find the 3 errors. Using focus mode thinking, you'll probably find the first 2 very quickly. You may need to use diffused mode thinking to find the 3rd error with this sentence. Here's the 3rd one. You have these 9 dots, and you're supposed to connect the dots with 4 continuous straight lines. So for instance, here's 1, 2, 3, 4, but you see I didn't connect all the dots doing that. Large projects are ideal for spaced learning and for diffused thinking. So if you have a large project like senior design project or a big programming project or a long paper you have to write, you should start right away. Okay, if you start right away and do a little every day, then you're doing this spaced learning, and you're also giving a lot of time to have diffused thinking during the duration of the project, because you're going to continually run into situations where you can't figure out how to take the next step. But by putting the problem away, allowing some diffused thinking to occur, coming back the next day, you probably have an idea of how to proceed on the project. In part 3, I am going to talk about deliberate practice and testing.